In this video, let's see the difference between mutually exclusive and independent events. Let's start tossing a coin. The probability of get a head is 0.5 or half, and is given by this red circle. The probability of get a tail is also half, and it's represented by this green circle. See that there is no intersection between these two sets. If you flip a coin, or you get tail or you get head, but not both at the same time. We say that the events head and the tail are mutually exclusive or disjoint events. My question is, are these two events independent? If I ask my students from PhD and Master in Economics to write a Venn diagram representing two independent events, they draw something like that. Two sets without intersection. I would say that 95% of students would draw events like what you are seeing right now. However, these two events are dependent. And why? If you know that the event head occurred, you know automatically that tail didn't occur. Therefore, knowledge of one event, it helps you to understand the other event. And this is the concept of dependence. But if I flip a coin and flip a coin again, these two events are independent because the first event cannot affect the probability of the second event, and vice versa. It doesn't matter how many times you flip a coin or the results of the coin. The probability of head or tail will be half. Let's show mathematically that the event head and the event tail, they are dependent. If the joint probability of head and tail is different than the marginal probability of get head times the marginal probability of get a tail, these two events are dependent. What is the intersection between h and t? 0. Therefore, the probability of the head and tail is just 0. And what's the probability of the head times tail? 1/4, because half times half. Therefore, we prove that events h and t are dependent, as this probability is different from this probability here. If you get equality here, then these two events would be independent.